A piecewise function is a piecewise function. It's a function made up of different pieces. Not clear? All right, let's find out. A function that is defined in different pieces across a domain. Can you see this? For values of x less than or equal to 2, it's defined by this straight line, minus 2x minus 1. And for values of x greater than 2, it's defined by another straight line. So literally, it's two different pieces of straight line that make up the same one function. It's the same one function f of x that's defined in two pieces. Can we have three pieces? Why not? Can we have four pieces? Why not? Can we have different kinds of pieces? Meaning, can it be a straight line and a combination of, let's say, a part of a quadratic or an absolute function? Why not? So as I said, a piecewise function is a piecewise function. It's one function defined in different pieces, however many pieces, two or more. But the main thing is, it's the domain that's controlling these pieces. So for this example, x less than or equal to 2, the piece that defines this function is negative 2x minus 1. So let's see how we graph a piecewise function. So we have x less than or equal to 2, negative 2x minus 1. It's a straight line, a very simple example. X equals 2 is where we have the two different pieces or the definition of the function changing. So that's going to be an important point to consider. So that's the x-axis. X equals 2 is going to be one important point to consider. The y-intercept of this line, the first line is negative 1. Where's negative 1? It's out here. And the x-intercept, but y is equal to 0 to get the x-intercept. And when you solve that, you should get x is equal to a negative half, I believe. Okay. I'm just approximating these points. Make sure that you get it on the right in the graph paper. This is just an approximation. And I'm going to try and use a tool from here just to keep the line straight. So let me just see whether I can get this thing right. Okay, that's the line that goes there. And I want to extend this line a little further down here. So further down up until x equals 2. There we go. That's the line. Okay, I think I got it right. There we go. Okay, so what I'm going to do is that x is equal to 2. At x equals to this line is still defined. So, I've got that solid line, solid circle there to indicate that x equals 2 is defined by this line, right? So at x equals 2, the value of the function, if you were to write f of 2, it's defined by this function. So it would actually be negative 2 times 2 minus 1, okay, that function. And so it will be a negative 4 minus 1, which is a negative 5, all right? Defined by, because that's, x is equal to 2 is defined by that piece of the function, right? That's how we interpret the piecewise function. For values of x greater than 2, you'll evaluate using this definition, x greater than 2, this second definition. Let's just check whether we're getting the same value that y is equal to negative 5 when x is 2, right? So on the graph, this is negative 4 and that is negative 5. And so that means our graphing is good. The second piece is negative x minus 4. And remember, that's x greater than 2. So on the right-hand side of 2, negative x plus 4. So what is the x-intercept of this line? X-intercept means y is equal to 0. So that should be 4. Here we go. The x-intercept is 4. And the y-intercept is going to be 4 also. So we got to be careful how we draw this line, okay? Because it's not going to be on the left-hand side of 2, okay? Let me use another color, red color perhaps, and I'll use the same drawing tool. I'm going to start from here. Although I'm starting from here, we need to adjust that because, the second line is being defined from 2, right, on the right-hand side. So, they're not there. This way, please. You're not used to these tools. That can be a little tricky. And I'm going to adjust that starting point of this line, okay? So let's first select the line. There we go. And I'm going to move the starting point of this line to there. There you go. All right, now we've got it. So what I'm going to do is I'm going to put a circle there. Okay, is that clear? Right, so this is just for the reference I put there for the y-intercept initially to get that line right. But the circle indicates that at x equals 2, the function value is here, not here. So indicating that with the circle and this with a solid circle. Okay, clear circle, all right, and a solid circle there. So that's going to be the graph. And for any function value, let's say we want to find the value of the function let's say f of 5, all right, because x is greater than 5, you're using the second definition. So according to the second definition, can you guys see this? All right, using the second definition, it's going to be negative 5 plus 4, which is going to be a negative 1 if you use the definition, okay, negative 1. And now let's just check with the graph, okay, what the value of the function is at x equals 5. At x equals 5, this is x equals 5, and there we can see even our graph, the second piece of the graph is correct. Let's have a quick recap. This is a piecewise function we're talking about. A piecewise function is a function which is defined in many pieces according to the domain restriction, okay. This is called a domain restriction. How the domain, the restricted domain, defines different pieces of the graph, and you can graph it accordingly. But remember, at each piece, be careful how you label. You know, the end of a piece cannot be on both ends, all right. One piece will have one end, the other one will be a clear circle, as we saw in the case of this particular function given by the two different straight lines. Now what I want to do is that I want to try and show how we draw piecewise functions on our graphing calculator, and we can also check whether what we have graphed is correct, right? So let's go to the graphing calculator now. I'm going to bring on the graphing app, and in order to enter a piecewise function, you can go and use this template, the template key, where we can use depending upon the number of pieces, okay. So this one is for the 3 piece, and this is 2 pieces, and you can have many other pieces also. So I'm going to use this one, and the first piece was given as negative 2x, so I'm just going to enter negative 2 times x minus 1, and here I can put down the domain restriction, and here we have x is less than or equal to 2, all right. So let's bring on that condition less than or equal to 2 here, and here we can type in the other piece that is a negative x plus 4, and that was x greater than 2, greater than 2, right? As simple as that. And then when you hit enter, you get those 2 pieces of the graph there. Of course, in the graphing calculator, you'll not be able to tell what's happening at that end point, but as I showed you on the on my OneNote that indicate this correctly when you're sketching the graph, that is there only to help you check your work. The real power of piecewise functions will come about when we actually test the continuity of these functions around the point where the definition of each piece changes, okay? When we talk about continuous functions, that's where we need to check the continuity of the function. So we'll talk about continuity on some other video. This was just to give you a basic idea of what piecewise functions are and how we evaluate the function value based on which piece that you look at, okay? And we also saw how we can graph piecewise functions on your graphing calculator. So I hope this video was useful to you. I'm going to see you all in the next video.